Finally comes the character frequency analyzer, which is part 4, the final test. This um, this part of the program goes through or reads the text file and records or counts the number of unique individual character occurrences in that text file. That's a basic purpose of this analyzer class. So first off, we make um, a hash map, a linked hash map, so that the order is maintained. Then we initialize the um, variables, which are the vowel count, the single character count, and the word count, each containing their respective roles and stuff like that. First thing we want to do in the perform analysis while reading in the text file is clear the character counts. So clear all the map contents and reinitiate the other attributes. So just set everything to 0. It's going to find that we're starting again and we don't want to keep all the stuff from before. Next, we'll select the file to be analyzed, read the next word in the file, and while the next word is not blank, we'll extract each character from the next word and add it to the occurrence map, as shown in here. This for loop keeps going for the whole length of the word. We will we'll get the character at position I with the char at function, and that's I represents the number, obviously, that we are in the for loop, and then we'll assign that part or that character from the word into the character Z, which we'll use later on. And then we'll check if the preset in the map, we'll check if it's present in the map, sorry, and then increment the occurrence count as shown here. If it is there, we'll just increase the number of times it's appeared. If it's not there, we'll put the number of times it's appeared as 1. Then moving on, we'll check if it's a vowel using this if statement, using A, E, I, O, U in both capital and lowercase right here. And if it is a vowel, if it satisfies this if statement, we will increase the vowel count. Then if the next word, so if the word is equal to 1, so if it's just a single character, the whole word, like A or something like that, then we'll increase the single character count. Then if the word length is 1, we'll increment it we'll increment word count. Word count is just counting the number of words that we've gone through, really. So yeah, that's it for here. And yeah, as you can see, Z is used in this if statement here. Moving on, the report that's generated for get most popular character. This will find the most popular character. If it's the highest occurrence count so far, we'll record the character in max. So we'll just go through this for loop. We'll get the value of the value of how many times that character has occurred, and if it's more than the current max, that value will just replace that with the max, and then we'll return the character. This is similar. Get most popular character count is the same thing, except this time we'll be returning the value rather than the character itself. Then there's get unique character count, which similar again. we're just counting over the whole um, set, that is character counts, and just counting how many characters are there, returning that. And then get vowel count, just returning vowel count, obviously. Uh, get non-vowel count. For this, we have to create two variables. Um, Basically, just the total amount of characters minus the amount of vowels, which as you can see is all calculated here, and then we'll return that. And then for get single character word count, we just return that. Get multi-character word count, it's the word count minus the single character count, and yeah, we just return that. And then for the get count of, which just returns the um, the amount of characters, the amount of characters for a certain character that have appeared, and for that we can do that in this one line. Return char counts dot get, and then character, and if it's equal to null, as in if there's nothing, if there's no occurrence of the character, we just return 0. But if there is it there, we'll obviously return the value it is. And that is the um, character frequency part of the module, part 4, character frequency class. For that, we will, uh, as you can see, it extends the base analyzer, meaning it can use everything the base analyzer can use, much like the other classes. We'll now run the test to see if it works. Which it does, as you can see. And then we'll run the whole um, project just to see the results. As you can see in the console, everything works as it should. This is um, the result that should come out. Thank you. Finally is the car frequency analyzer. This basically just takes the characters from a text file and analyzes it across another text file. So for this, we can create a linked hash map with character as the key and integer as the value. The variables are vowel count, single character count, and word count. For the analysis, we'll clear up the map contents and reinitiate other attributes, setting them to 0 and just using the .clear function. We'll select the file to be analyzed, read the next word, and then process all available words. And then we'll extract each character from the next word and add it to the occurrence map, as shown here. And then we'll check if it's present in the map, the character that is, and then increment the occurrence account if it is. If it's not, we'll just put it as 1. And then we'll check if it's a vowel using this if statement, checking if it's a capital letter vowel or a lowercase letter vowel, and if it is, we'll increase vowel count. And then we'll also check if it's just a single character using this if statement, and if it's so, we'll increase the single character count variable. We'll also, for each time this goes through, like each time a word is entered, we'll increase the word count to make things easier for ourselves later on, and just increment word count, increasing it by 1. And then obviously read next word. Then for public character, get most popular character, this finds the most popular character as it states. Um, if it's the highest current count so far, we'll record the character. So just that's the logic behind this. We'll go through everything, and then if it's higher than the max, which starts at 0, then we'll just make it the new max. If it's not, we'll ignore it. And we just go through that continuously and then return character at the end. And then forget most popular character count, it's similar, but this time we'll be returning the value rather than the key. So rather than the character, then just return the max value of that. For get the unique character count, we'll just count the amount of characters in car counts and return that just to get the amount of characters that we recorded. And then for get val count, obviously we just return val count. Get non-val count, we'll do the calculation of taking away the get non-val count. We'll take away the total val count. We'll take away the total count from the total amount that's in car counts from the amount that's in val count, as you can see in this equation. So we'll just add up all the values in car counts, and then we'll just take away the amount of vowels there. And then we'll return it here. And then for get single character word count, just return that. And then get the multiple character word count. For that, it's just the word count minus the single character count. So that will obviously get us the amount of the words that are just made out of multiple characters rather than one. And then for get count of, which obviously just returns the count of any character the user puts in, we'll return. We can do that in one line. If the character doesn't have a value, then we'll return 0 because it's not been recorded yet. And if it does have one, we'll just get that. And that is the character frequency class. It much like the others, it extends from the base analyzer, so we can use all the classes in that. Start to mention that, and then we'll test it, see if it runs. Which it does. All the tests are running, so that's completely fine. Then finally, for the finishing touch, we'll just quickly run the whole test, the whole project, like so. You see the output. As you can see, all the output is fine. Thank you very much.